this video, we will learn how to find the equation of the inverse of a function, and we'll sketch the graph of a function and its inverse on the same coordinate plane so you can see how they are different. What is inverse relation? Say every day you drive from home to work from point A to point B to point C. And in the evening, you take the same road and drive back home from work, now in reverse direction, from point C to point B to point A. Inverse function has a similar relation to this situation. For example, if function f is given by the set of points f of x equal 3, 2, -7, 4, 5, -8, then the inverse of this function will be a relation, say g of x, 2, 3, 4, -7,
-8,
5. As you notice, to find the inverse of the original function f of x, we switch the input and output values, x and y. Inverse function f of x is abbreviated as f inverse of x. Don't confuse the little -1 exponent with the exponent. This is not exponent, this is abbreviation for the inverse function. Let's look at a few examples.
Remember that a function is a relation in which each input value has a unique output value. If the function has the inverse that is also a function, then there can be only one y value for every x value. This type of function is called one-to-one function, a function in which every element in the range comes from exactly one element in the domain. To identify from a graph if a function is one-to-one, we can use horizontal line test. If a horizontal line crosses the graph in more than one point, then the function is not one-to-one function. If we check the sine graph or the graphs of other trigonometric functions, we will see that there are not one-to-one functions. For example, looking at the sine graph, we see that the horizontal line crosses the graph in multiple points. That means that even though sine graph just represents a function, the inverse relation will not be a function. But there is something we can do about it. I'm going to build an inverse of y equals sine x using Desmos graphing calculator. To find the inverse of a relation, we simply interchange x and y values to obtain x equals sine y. Let me just adjust the y-axis to radian measure as well. We can observe that x equals sine y reflects y equals sine x about the line y equals x. Let me hide the original sine graph so we can take a look at the inverse sine graph. In order for the function y equals sine x to have an inverse that is also a function, it's necessary to restrict the values of y to a certain interval. The interval we restricted to is the interval from -π/2 to π/2. By doing that, we now have a function in which each x value is associated with exactly one y value. Let me adjust the steps on both axes to π/2 and zoom in so we can see the graph more clear. We can abbreviate the inverse of sine function as y equals sine inverse of x or y equal arc sine x, where y is the angle between -π/2 and π/2. Let's take a look at the other inverse functions. The inverse of cosine function is abbreviated as y equals cosine inverse of x or y equals arc cosine x, where y is the angle between 0 and pi inclusive, whose cosine is x. And the inverse of a tangent function is abbreviated as y equals tangent inverse of x or y equals arctangent x, where y is the angle between -π/2 and π/2, whose tangent is x.
If you find this video helpful, click the like button and subscribe to my channel. I have new videos coming up every week. I'll see you next time.